We're now going to begin section 8.2, where we will discuss polar coordinates and the polar coordinate system. We're going to begin by comparing rectangular coordinates, which are the coordinates that we learned in, say, an algebra class, to the polar coordinates, which are more trig-based. So recall in algebra, when you are talking about plotting points, that every point has an x value and a y value. So if we have a coordinate with an x and a y, we are talking about a rectangular coordinate. In trig or pre-calculus, when we're talking about polar coordinates, these coordinates will have an r value and a theta value. And so you want to identify a coordinate that has an r and a theta as being a polar coordinate. When you graph a rectangular coordinate, remember that you graph a rectangular coordinate on an x and y axis. So for example, if we're graphing the point 3, 4, we're going to go over 3 on the x-axis and up 4 on the y-axis and intersect and place our point. If we're plotting a polar coordinate, the graphing system will look quite a bit different. So an example of a polar coordinate might be 3 pi over 4. And so in order to plot 3 and pi over 4, we would first want to draw our angle. So remember that a pi over 4 angle is like a 45-degree angle. And then the r value is tick marked off on the terminal side of the angle. So we would have 1, 2, 3, 4. And if our r value is 3, we would plot our point at 3. If our r value was negative, say for example negative 2 pi over 2, then we would begin by drawing a pi over 2 angle. Again, our positive numbers will be tick marked off on the terminal side of the angle. So here we have positive 1, positive 2, positive 3, positive 4. If we want negative 2, we're going to see that on an extension in exactly the opposite direction of the terminal side. And we're going to have negative 1, negative 2, negative 3, negative 4. We'll place our point on negative 2. And so the r value is going to be a measure of the distance from the origin or from the vertex of your angle to the point. If it is a positive value, it's going to fall on the angle itself on the terminal side. If it is a negative value, it's going to fall in exactly the opposite direction than that of the terminal side of the angle. So let's look at a couple of other examples, and what we're going to see is that when we're plotting polar coordinates, often we are plotting them on a type of graph paper that looks very similar to the unit circle. Right? We have that here on the screen. Our first problem asks us to plot the point given by the polar coordinate 2 and 3 pi over 4. So what you want to recognize on this graph paper is that each line represents 15 degrees. Okay, so we can see that here. Let me just show you how this is going to work. This is our initial side, and I'm just going to draw out a 90-degree angle here so that you can kind of see that first quadrant. All right, so this is 15 degrees, this is 30 degrees, this is 45, this is 60, this is 75, and this is 90. All right, and so each line represents an angle with a 15-degree increment. Okay, so if I want to plot 3 pi over 4, it may be to our advantage to think about that in terms of degrees. Okay, so remember that To convert something to degrees, we are going to multiply by 180 over pi. And this isn't absolutely necessary because you may be able to plot it in radians without any difficulty, but if you can't, you might want to convert it to degrees first. So this is going to end up giving me 135 degrees. All right, which then I can come in here and draw out that angle. Okay, again, so this is your initial side. We know that straight up is 90, so I'm going to kind of keep adding here. So 90, this is 15 more would be 105. 15 more would be 120. 15 more would be 135. So here is our angle that we are referencing. Okay, and then if our R value is 2, that means that we are going out 2 units on the terminal side of the angle. So here is the first tick mark when this first circle comes around. Here is the second tick mark when the second circle intersects. And so our point is going to lie here. Okay, now it's worth noting that really the only thing that we're concerned about when we're asked to plot a point is the actual point itself. And so oftentimes you won't see any of this other work that we needed in order to graph the point. You'll simply see the point plotted. Okay, it's not wrong for you to graph the angle first, but the actual answer is truly just the point. Okay, so let's move on and let's look at our next one. Our next one is negative 5 pi over 2 for the angle. All right, so remember if it's negative, we are moving in a down direction. All right, so here is my initial side. I know that if I dropped down to here, I have gone a negative pi over 2. And if I continue to here, that's going to be pi, or actually 2 pi over 2. If I come up to here, I'm going to be at 3 pi over 2. Here would be 4 pi over 2, right, or 2 pi. And I need to go one more, so this is going to be 5 pi over 2 right here. All right, so I'm going to drop my line down. That's the other part of my angle. Now, my R value is 3.5, and so we're going to look at where these circles intersect. So this is going to be 1, this is going to be 2, this is going to be 3, and this will be 4. So 3.5 is going to sit right in here. Okay, and again, the only thing that really is important here is the point itself. And so now that I know where it's at, I'm going to erase the rest of this. And we have our point at 3.5, negative 5 pi over 2. Okay, so our last one, we have negative 1 and 4 pi over 3. And again, you may want to take a minute and identify that 4 pi over 3 converted to degrees, multiplying that times 180 over pi is going to give you the equivalent of 240. And so we want to be able to mark off an angle that is 240 degrees. So let's see, we know that straight up is 90, we know that straight across is 180. So we're going to say 180 and another 15 would make 195, another 15 would make 210, another 15 would make 225, and another 15 would make 240. And so here is the terminal side of our angle. Okay, so that is 4 pi over 3. Okay, and then note that we are asked to put the point on -1. So remember that the negative r values are going to tick mark backwards. And so it goes in exactly the opposite direction from our angle. All right, let me get this out of the way so we can see this a little bit better. All right, so we are going to see this thing come back and extend back this way on the negatives. And we're going to place the point at -1. So -1 will be the first intersection of the circle. All right, so this will be the point -1 and 4 pi over 3. And so again, worth remembering is that if your point has an r value that's positive, your point is going to lie on the terminal side of the angle. And if your point has an r value that's negative, it's going to lie in exactly the opposite direction than that of the terminal side of the angle.